Each time an incident involving hazardous materials occurs, several questions require immediate answers. What type of material is involved? What are the material's characteristics? Is it a PIH, corrosive, flammable, or a combination of problems? Will environmental and weather conditions help or hinder the situation? As an emergency responder, it's your responsibility to make safe, educated decisions upon arriving at the scene of a spill. Among the most common materials you'll encounter are DOT Class 3 flammable liquids. It's important for you to understand some of the main properties associated with these flammable and combustible liquids, such as flashpoint, flammable range, ignition temperature, and vapor density. We know that Class 3 materials will burn, but what conditions need to occur to cause a fire? Does a spark or flame need to be present? What areas of the spill are the most volatile? How hot does the material or ambient air need to be, or vapors to form and then ignite? If responders can identify the characteristics of a hazardous material, then a focused plan of attack can be created to deal with the incident. When will a material ignite? This depends on the material's temperature and its flashpoint. Flashpoint can be defined as the minimum temperature a liquid must reach to produce enough vapor to allow for combustion. For DOT Class 3 liquids, these temperatures most often range between 0 degrees and 200 degrees Fahrenheit. Flashpoint is the single most important property of a flammable or combustible liquid. The material must reach the flashpoint in order to generate invisible flammable vapors. If the material has not reached its flashpoint, the material is not ready to burn. Flashpoint doesn't cause ignition. It only allows for production of vapor so ignition can occur. It's very important for you to understand that it's not the liquid that burns, it's the invisible vapors which fuel the fire. The flashpoint temperature is the value that determines if the substance is warm enough to produce those invisible vapors. For instance, gasoline. Its flashpoint is about minus 40 degrees Fahrenheit. This low flashpoint value means there will almost always be enough vapor to allow ignition to occur. These containers are sitting in an area where the temperature is 70 degrees Fahrenheit. The first container is full of gasoline. As we've just learned, the flashpoint is minus 40 degrees Fahrenheit, so sufficient vapors exist here for a flammable mixture with air. The liquid in the second container has a flashpoint of 50 degrees Fahrenheit. Again, sufficient vapors exist to allow for a flammable mixture with air. Container 3's liquid has a flashpoint of 100 degrees Fahrenheit, and Container 4's liquid has a flashpoint of 140 degrees Fahrenheit. Since the flashpoint of these last two containers is higher than the ambient temperature, enough vapor to allow for a flammable mixture with air would not exist. A flammable liquid like kerosene, which has a flashpoint just above 100 degrees Fahrenheit, may require additional heating to produce vapor. This would depend on several environmental and ambient conditions. Is it a cold or hot day? Is the material spilled on hot pavement? Has the container been exposed to direct sunlight? These are some of the many questions emergency responders must ask in order to evaluate an incident. If a material has reached its flashpoint, where can it ignite? Ignition takes place in the material's flammable range. It's defined as the percentage of flammable vapor in air in which ignition must occur for sustained combustion. Above every burnable liquid that's at or above its flashpoint exists an air-to-fuel mixture which is necessary for ignition. The richest, highest fuel percentage is nearest the liquid surface. The leanest fuel percentage with the least amount of fuel-air mixture exists furthest from the surface of the liquid. The lean end, where the minimum percentage of fuel in air exists, is known as the lower explosive limit, or LEL. The rich end, where the maximum percentage of fuel vapor in air is called the upper explosive limit, or UEL. Below the LEL, there is not sufficient fuel available for ignition. Above the UEL, the mixture is said to be too rich to burn. The flammable range for the majority of the DOT Class 3 liquids lie in the 1% to 8% range. Or, stated another way, the LEL equals 1% fuel with 99% air, to UEL equals 8% fuel with 92% air. Again, the flammable range exists between the LEL and UEL. In this range, ignition will occur if a suitable ignition source is present. What is considered a suitable ignition source? A cigarette? A match? How about a clothing iron? All three of these items are valid sources, each with a different ignition temperature. It's defined as the minimum temperature to which a material must be heated for the material to ignite. Actually reaching the ignition temperature is what causes a fire. There are several types of ignition. The two most common are pilot ignition and auto ignition. Pilot ignition occurs when a burnable liquid is at or above its flash point, and a spark or flame is introduced into the flammable range. Auto ignition occurs when a hot object, such as a burner on a stove or an overheated exhaust pipe on a vehicle, succeeds in raising the temperature of the liquid or vapor to the point where it ignites in the absence of a spark or flame. It is this property of ignition temperature that explains why a lit cigarette will sometimes, under the right conditions, extinguish when placed in gasoline. The ignition temperature of gasoline has not been reached by the cigarette, but striking a match would create a high enough temperature to ignite the gasoline. Ignition temperatures for the DOT Class 3 liquids range from approximately 400 degrees to 1,000 degrees Fahrenheit. Remember, the ignition temperature value determines the amount of heat required for a substance to ignite. This value may come in the form of any hot object, like a motor, a steam pipe, or a match. If a material has exceeded its flash point and a flammable range exists, where exactly is the vapor? As a liquid spills over a surface, it increases the concentration of vapor. Vapor density may be defined as the relative density of a vapor as compared to air, with air assigned a value of 1. Materials with vapor density values greater than 1 will tend to sink and accumulate in low areas. Materials with vapor density values less than 1 will tend to rise and disperse if unconfined. Vapors from the DOT Class 3 liquids generally possess vapor density values of 3 to 4. This indicates that these invisible vapors are 3 to 4 times heavier than air. Depending on environmental conditions, these vapors may travel downwind or downhill, accumulating in low-lying areas waiting for a suitable ignition source. These four properties, flash point, flammable range, ignition temperature, and vapor density, will determine how Class 3 flammable liquids are handled. Remember, flash point is the minimum temperature a liquid must reach to generate vapor. Gasoline's flash point is about minus 40 degrees. Kerosene's flash point is just over 100 degrees. Flammable range is the required quantity of fuel-to-air mixture capable of ignition. The richest, highest fuel percentage is nearest the liquid surface. The leanest fuel percentage with the least amount of fuel-air mixture exists furthest from the surface of the liquid. Ignition temperature is the minimum temperature to which a material must be heated for it to ignite. You may be able to extinguish a cigarette in gasoline, and you may ignite vapor with a toaster. Vapor density is the relative density of a vapor as compared to air, with air assigned a value of 1. As the surface area of the spill increases, the concentration of vapor increases. Density values for the majority of DOT Class 3 liquids are 3 to 4 times heavier than air. Many people's lives are at stake in an incident involving hazardous materials. The victims, you and your co-workers, and the people that live in the community around the incident. The next time a Class 3 material escapes its container, knowledge of these basic properties will help you to make safe, educated decisions upon arriving at the scene of a spill.